Good morning, everyone. Good morning, Charlie. Thank you, everyone, again for joining our interactive webinar this morning. The topic of Do you think you know all about electrical safety? So we're super excited about this webinar, and Charlie and I, we kind of looked at the 70E standard, and we kind of came up with few glaring questions or the questions that needs more clarity in terms of that leads to a lot of confusion among the audience. So we kind of queued up 12 questions. We're going to just launch those questions on the screen. So it's going to be like a question that will be displayed on your screen where you will poll your responses. What do you think is true or false, or select based on the multiple choice options. And then we will share that response on the screen to just not tell what is correct or wrong. It's about what most of the people have responded to those questions from the audience, and also talk through why, if someone would respond the wrong answer, what would be the reasons behind it. We'll just dive deep into that and kind of give that explanation on it. And as we are going to the webinar, please feel free to type in your comments using the webinar dashboard or console what you have, and then we'll try to take those feedbacks and answer those questions. And additionally, we had received about 10 to 15 questions as you are registered for the webinar. Those have been entered in from some questions on 70E as well. We'll try to answer those as well as time permits. Okay. So without any further delay, I will poll the first question on the screen, and we'll leave it on the screen for 10 to 15 seconds. So look at the question and post your response, and we will tell you what the correct answer is. Here you go. Do you guys see my screen?
Yes.
Okay, that's good. So they're still polling. Still coming. So we'll give another 5 more seconds. Looks like it's almost stabilized here. So, all right. So I'm going to share the response on the screen. Okay, so 40% said the question was the arc flash boundary is always beyond the limited approach boundary. The answers were true or false. 40% said it's true and 60% said it's false. Charlie, you want to just go and explain what's the correct answer and why it is so?
Yes, the correct answer is false. It's the limited approach boundary is a shock boundary, and for up to about 750 volts, the limited approach boundary is for a fixed type of equipment is 3.5 feet. Now the arc flash boundary is not dependent upon that shock boundary whatsoever. I personally have seen the closest arc flash boundary I've ever seen was 2 inches. I mean, that is just not, and that was a panel board, a 208 volt 3-phase panel board. That is the closest boundary I've ever seen, 2 inches. The farthest arc flash boundary I've ever seen is 235 feet, 8 inches. And there's a good reason why it was that distance, but I'm not going to get into that today. But the answer is false. So the 60% of the people got that right. You can pat yourself on the back.
So can you just explain why would someone think, because there is a reason why someone would think it's true as well, right? So do you want to just go and explain what would be the reason from that perception?
It really just, it seems like, oh yeah, you're going to get an explosion. You're going to get the arc flash boundary certainly seems like it is going to be further out than 3.5 feet. It sure seems like that, like it would be that all the time, but it's not. I've seen plenty of 5, 6, 7 inches as arc flash boundaries. So this is a very common mistake, and if someone this is not going to cause a problem whatsoever. If somebody, it didn't matter if everybody were to wear arc flash, arc rated clothing within 3.5 feet, regardless, even if it's 2 inches, that's fine. There's not a problem of overdressing for the arc flash boundary, it being too close.
Thanks, Charlie. Let's go to next question. So this is in accordance with NFPA 70E, how often employees shall be retrained in safety related work practices and applicable changes. So that's a question, and then the responses are 2 years, 5 years, 1 year, and the last one is 3 years. So we'll leave it on screen for 30 to 45 seconds, and then we'll go through the responses. If someone thinks it's 2.5 years or 3.5 years in half-year increments, we don't have that response. Sorry about it. Okay, I'm gonna leave it 10 more seconds and then close it out. It's a great question, Charlie. I mean, a lot of people really get confused with this question because the multiple aspects to it. So I'm gonna close it and then share the responses. Here we go.
Wow. Okay. All right. All right. So this is kind of the key to this question is in accordance with NFPA 70E. And in accordance with 70E, the correct answer is 3 years. Now, a company very well can determine that and have a precedent in their company that they're going to train their people each year or even every 2 years. I'm glad to see there were not many people that chose 5 years, because that's going a long time. But there are a lot of companies that I do. Of course, I do a lot of training. I do go to on-site, and I'm in Tennessee, but I travel all over the country. And in fact, unfortunately, next week I'm going to Syracuse, New York. I think I'm going to freeze my whatever off. It's going to probably be like it is in where Bhanu lives in Iowa. It's going to be freezing. But a lot of places, they'll say we're going to train our people every year or every 2 years. So those, and again, if you don't go according to 70E, if you go 1 year, 2 years, that's even better for safety, I believe.
Okay. So why would someone think, Charlie, 2 years or 1 year? I mean, the question I have follow up to that answer is it set stone like only 3 years they need to be trained, right? So you kind of answered it, but what would happen if there is a change to the equipment or the system level change to any kind of procedures or policies? What would happen at that juncture?
Yeah, the section for this is in 110.6A3. And if there's a change in someone's work description, a change in equipment that and they need training sooner than every 3 years, absolutely, that's going to be required.
Okay. Thank you. Let's go to the third question, which is, while testing for absence of voltage, test each conductor and circuit part and dash, fill in the blank. I'm just posting the question. Answers are face to face to ground, both face to face and face to ground. And the last one is both face to face and neutral to ground. We'll leave it there for about 30 seconds, 30, 45 seconds. All right, I'm going to close the poll and share the responses, Charlie.
Well, the answer is that most everybody got is correct.
Yep.
Phase, both phase to phase and phase to ground. The last one was kind of a trick question because your neutral to ground is should be you should get a potential of 0 anyway, so that really shouldn't come into play. But where this is located is where 70E tells us that it gives us a requirement for verifying and establishing and verifying that equipment is in an electrically safe work condition. 120.5, and this is paren 7, 120.57. This tells us talks about testing for the absence of voltage. And we have to, in testing, phase to phase and phase to ground. And so if it's single phase, then it's just the 2 hot conductors or ungrounded conductors, and then each ungrounded conductor to ground, which could be, you could test it to neutral, a grounded conductor anyway. And then 3 phase, of course, A to B, B to C, and A to C, and A to ground, B to ground, C to ground.
So here is my question to you, Charlie. So what would be the procedure if it is a 5-wire system? Okay, so just for clarification purpose. So if it is a 3-phase and ground and neutral, do you recommend also verifying neutral to ground in that scenario if it is not commonly grounded?
I'm not sure about your question.
If it is a 5-wire system like international, I mean, foreign countries, some countries use 5-wire systems, right? So it's a L1, L2, L3, neutral and ground. Okay, if the neutral and ground are not bonded together, in that scenario, do you recommend as a safety measure to verify for any stray voltage between the neutral and ground as well?
Well, you can. It's not going to hurt to check phase to neutral, and even checking neutral to ground. There should be 0 potential electricity there, neutral to ground, even though the neutral is isolated from ground. And typically, if you're familiar with the National Electrical Code, we bond the neutral to ground at the service entrance, in the service equipment. Once we go away from the service equipment, the neutral and ground are not bonded together. The neutral, typically we call it isolated. In a panel board, we do not install the green main bonding jumper. The neutral is isolated from ground. But if you want to test to see if there's any potential difference between the neutral or grounded conductor and ground, that's fine. There's not a problem in doing that.
Sure. Thanks, Shirley. Thanks for the clarification. Let's go to the next question. Is it safe to work without arc flash and shock PPE after verifying and establishing an electrically safe work condition? I'm going to post this question on the screen. I'm going to leave another 15 seconds. All right, closed. Let's share. This is interesting, Charlie.
The answer to this is yes, it is safe. Once you have established and verified that the equipment is in an electrically safe work condition, you can remove your ARC rated PPE and your shock PPE. Because
unless you are in love with your PPE.
Do I now?
Unless they are in love with their PPE, they're allowed to wear the PPE and work. So.
Oh well, yeah. I mean, by all means, if you're not wearing anything under your arc flash suit, then by all means keep it on. But yeah, you don't need. The section of this is 120.5. It's NFPA 70E 120.5.
Okay. So I mean, why would people think that is not the case, right? So you want to explain on that, Charlie? Some people think
yeah,
it's not.
And this is all of these questions are a lot of times when I go to a plant to teach, I'll ask them or they'll ask me to provide a test, a written test, and a lot of places want the test before the training and after the training. Now, after the training, everyone in my class should be getting all of these correct. But this is one that even on the front end, a lot of people think you have to continue wearing the ARC rated and shock PPE. But once you put the equipment electrically safe, then it's part of that is not just testing for the absence of voltage. You've got all these 7 or 8 steps that are necessary, including lockout tagout, which lockout tagout itself has multiple steps. So the equipment is locked out, tagged out. You've tested it for the absence of voltage. You've tested your test equipment before testing for the absence of voltage, and you've tested after. And so everything is electrically safe at that point. And there's no reason that you would have to keep your arc flash clothing on, your shock PPE. Okay, so what if you're wearing maybe coveralls, and so instead of having to just take them all off, and maybe you've got a hard hat with a face shield and a balaclava, and you want to take that off, that's fine. Leave on what you want to, but make it comfortable where you can work easily at that point. And once it is in an electrically safe work condition, someone can walk into that where there is no arc flash boundary, there is no shock boundary at that point.
Yep. Thanks, Charlie. Let's go to next question, which is, so there's a statement, it is not necessary to visually verify all blades of a disconnect switch or fully open as long as absence of voltage is tested. Here, the true or false? Okay, I'm gonna close this. There you go. And here are the responses, Charlie.
All right, so this is from the same section, 120.5, which covers the process of establishing and verifying an electrically safe work condition. I mentioned there are 7 or 8 steps. The reason I keep saying 7 or 8 is because typically step 8 is for over 1,000 volts, because that is installing temporary electrical safety grounds. But we have to do all the steps that are necessary, which we may not. If it's a 480 volt system, we're probably not going to install temporary electrical safety grounds So that's going to eliminate step 8. Well, one of the steps, step number 3, specifically says wherever possible, visually verify that all blades of the disconnecting device are fully open, or that draw out type circuit breakers are withdrawn to the test or fully disconnected position. And it says wherever possible, visually verify. Can we do this on a molded case circuit breaker? Well, no, we can't see inside that circuit breaker that the contacts have separated. So that's not possible. A disconnect switch, a safety switch, it is possible to open this disconnect switch up and visually verify the blades are out. Well, I've talked to a lot of people. I've never seen it personally myself, but I've talked to a lot of electricians and maintenance people that have opened a disconnect, and either 1, 2, or 3 blades were still attached. Now, that is just one step. We still have to go continue with all of the steps, including testing for the absence of voltage, but still that is step number 3 that we have to be doing. So it doesn't matter as far as it just tells us this step needs to be done. We need to, if it's possible, visually verify that the blades are out. If it's possible, visually verify that the rack-in type circuit breaker, the draw-in, draw-out type circuit breaker, is close to the door, and that it could not be energized in the position that it's sitting.
Okay. So the correct answer is false. 66% answered it correctly. So that's good. So let's go to the next one. Under what conditions energized electrical work permit is not required if a qualified electrical worker is provided with safe work practices and PPE? So the responses are testing, troubleshooting, voltage measurement. Last one is any of the above. This is an interesting question, Charlie.
Do it.
I said this is an interesting question. I'm going to leave for 5 more seconds and close it. There you go. Now share the responses.
All right. The majority of the people got this correct. So it is any of these. If you can test, you can troubleshoot, you can measure voltage, and these are exemptions from not having to have an energized electrical work permit. Well, where's this located? I'm glad you asked. 130.2 C1, 130.2 C1. It gives us some other exemptions of having to fill out and having to have an energized electrical work permit, but these are absolutely exemptions. Testing, troubleshooting, and voltage measuring. So, all right, this is if you were taking a test like this, and you're saying, okay, wait a minute, I know that testing and troubleshooting are correct, but I'm not sure voltage measurement is. Well, all right, if you know the testing and troubleshooting are correct, there's not one that just says those two only, so it would have to be any of the above. So if you know that 2 out of 3 of those are correct, then you need to answer any of the above, which the last any of the above is the correct answer. 130.2 C1.
Okay. So Charlie, just a follow-up question on that. Can you also clarify on in which circumstances an energized electrical work permit shall be required?
Well, okay, in 130 the same section, in 130.2C, and it talks about that if we do work within the restricted approach boundary, and if you're working within, typically the restricted approach boundary is going to be for up to 750 volts is going to be 1 foot. If you do work within 1 foot, then that would require an energized electrical work permit. In the annex, in the back of the informative annex in the back of 7E, there's a matrix, there's a chart that you'll work through to help determine if you need an energized electrical work permit. And the big thing is, are there exposed energized parts? Are you going to be within the restricted approach boundary? Are you going to remove anything? Are you going to replace a part? And here's one thing that a lot of electricians and maintenance people don't think about. They don't realize that, all right, you've got a disconnect switch right at a pump, and one of the fuses blows. And so the electrician or maintenance person goes over there, maybe they suit up, hopefully they suit up, they open it up, they test, they know that there is a fuse that's been blown. So they replace, and typically what they'll do is replace all 3 fuses. But if they're replacing that fuse and they are within the restricted approach boundary, which more than likely they are going to be, then that is doing work, and that would require an energized electrical work permit. And so I'll ask them in class typically, all right, is it going to be easier and quicker for you to fill out an energized electrical work permit and get somebody to sign off on this, or go upstream and find the disconnecting means and disconnect this safety switch? And the response, of course, always going to be, well, it's going to be easier to go upstream and disconnect it, lock it out, tag it out upstream, than to get somebody to sign off on this. One thing, they're probably not going to get someone to sign off on it. The other is it could take quite a while. So, but testing, troubleshooting, voltage measuring, these do not alter anything. These are not replacing anything. They're not replacing a component or anything.
So a follow-up question from audience here. Isn't voltage measurement a form of testing or troubleshooting anyways?
I'm sorry, I didn't understand the question.
The question is, isn't voltage measurement a form of testing or troubleshooting?
I don't know. I could see that being. I'm not sure how to answer that one. I know all 3 are in 70E, so I do just well, all 3 are in there: testing, troubleshooting, and voltage measuring, or voltage measuring.
Okay. So what about touch-safe equipment? Touch-safe equipment, what about in that case?
All right. So in this finger safe or touch safe, there are disconnect switches out there that are designed that they are finger safe and touch safe. All right, so it would be up to the company, up to the facility, to do a study, determine if that would be safe for them or not. I know that I do a risk assessment. Some companies have done that, and they may determine that, all right, if it is finger safe or touch safe, then it would be okay to replace a fuse once the disconnect switch is closed or is opened up. But I would think a lot of companies would say, no, even if it's finger safe or touch safe, we want it shut off upstream from that.
Thanks, Charlie. I'll go to the next question. In the process of voltage testing, do you need to retest the meter after face-to-face and face-to-ground has been tested? This is per article 120.5 step 7. Is it required to retest the meter after the absence of voltage test has been done?
And some places, some people, and I like this term, some people call it live dead live testing. So that's what the question is asking. After you test you test your meter to make sure it's working, you test phase to phase and phase to ground, and then what the question is asking, do you really need to test your meter again after testing phase to phase and phase to ground?
All right, so I'm going to close the poll. So 32% true and 68% false. So go ahead, Charlie. I think I have a comment on this, as you know. So go ahead.
All right, so that is false. 120.57, we absolutely have to test our meter. And Bhanu, if you can go ahead and show the screen of us. All right, you test your meter on a known voltage source. And I don't sell any products, but I take a lot of things to class. One of the things, if you've never seen this Fluke device, it's called a proving unit, and this has 4 AA batteries in it. This gives you a voltage. Sometimes if you're out somewhere and you're working in a plant, finding a 120 volt receptacle may not be very easy. Well, with this device, you can check your meter. You can just actually clip it to the metal enclosure or even the enclosure next to where you're working, and you can test your meter. And then you can test for the absence of voltage and test your meter again. Now, when I do training, a lot of times I will do hands-on training either the same day or the day after. And I will tell attendees that remember live, dead, live. Because if you can remember live, dead, live, that last step is so stinking easy to forget. Electricians, maintenance people, they will test test their meter, and then they'll test phase to phase and phase to ground. And even when I'm working with them, they'll put the meter down and say, okay, it's safe. And I go, wait a minute, what are those 3 words you're supposed to remember? Live, dead, live. And most people absolutely know the correct answer on this, but doing it in reality is a whole other thing. It's just, and I see this all the time. I'm going to be in Syracuse, New York next week, and one day is going to be hands-on, or it is actually the hands-on training, and I will work with those people. I guarantee there will be people that will forget that last step. And so it's one thing if it's up here, but make sure that you test the meter on the tail end of this as well. And so this is 120.57. And so there was a question that came in earlier today from a gentleman, and we're not putting it up because it kind of rolls in through this one. And in the process of establishing and verifying, and what his question was all right, in testing for the absence of voltage, if we're doing it in an MCC, if we're shutting down the whole MCC, do we have to do it every time we open a bucket up? And if a company says that's what you do, well, that's above and beyond what 70E says. Well, in the next edition of 70E, and probably in the last webinar I talked about this, Bhanu and I have talked about this a lot, there's been a proposal, a first comment that was accepted, and I personally don't like it. All right, let me read what it's going to be. It's in the new edition right now. Now people can send in comments to get this removed, but right now they're wanting, or the committee is wanting, that for testing for the absence of voltage, that you test at each point of work. And so what's going to say is, use an adequately rated portable test instrument to test each phase conductor or circuit part at each point of work to test for the absence of voltage. Well, I've got several problems with that. One is, if we've got a cabinet, and I know I have a very strong opinion on this. If you're going into a cabinet, an industrial control panel, and you shut the power off upstream before it gets into the cabinet, you open the cabinet on the line side of the breaker at the top, you test phase to phase and phase to ground. Now, typically, that is all that's done. Well, with this new wording, are you going to have to test each and every component in that cabinet? With the question that came up this morning, if I shut down the whole motor control center, am I going to have to test each cubicle, each box? Well, if this one goes through, the answer is going to be yes. Or here's one that's even crazy as well. We shut power off to a whole building, and we're going to remove all the electrical in that building. We shut it off, we disconnect it, it's cut loose. We tested for the absence of voltage, but now we're going to have to do it at each device, each set of conductors, and in reality, nobody's going to do that. Well, the other thing is, they're not adding a definition of at each point of work. What does that mean? Is the point of work the control cabinet? Is it the building? Is it the component? So this is one thing that's going to end up coming up, and I'm not sure if it's if the comment stage is opened at this point. But as soon as it's open, if you have a problem with this, I suggest writing something in. I know I'm going to write several things. Bhanu's probably going to write some things. We have some other people that are going to comment on this as well. It seems like what they're trying to do is, it's like, I'm saying I'm on the committee as well, but but it seems like they're telling us exactly how we have to do everything. And if we're a qualified person, we should know what to do. So I don't like the new wording at each point of work that's going in.
So if that is the criteria, Charlie, then in that case, should the worker be donned with the PPE all the time because he's testing at every point?
Well, that's kind of, it certainly seems like that may be where we're going with this. And so, all right, so someone's going to take the other side to argue, well, what if you tested it at the disconnect, and the motor is, or on the load side of the disconnect, it's locked out, tagged out, the load side is put into an electrically safe work condition. Well, and then the motor may be a remote location. Well, it absolutely, yeah, you need to test it there, because what if you locked out the wrong disconnect switch? So I mean, some of these things are really absolutely part of being a qualified person.
So since this has other side of story as well, right? So we have a question. Someone is asking, what if you have stored voltage, like capacitors discharging or a servo motor still spinning, putting voltage back into the system? What if in that scenario, right? So I think you can answer this.
Right. Well, okay, capacitor in 120.5, the number 4 says release stored electrical energy. And also when you're testing for the absence of voltage, if a motor's still spinning, it's still putting voltage in the system, in the circuit. So that would have to be, and that would even come under block or relieve stored mechanical energy. That would, with the motor still spinning, that would be mechanical energy because it's creating electricity like a generator, just sending it back.
So and also to that point, Charlie, you're absolutely right. I mean, as long as you can validate there is no back feed coming to that source that's been logged out, and through the following the steps on the 120.5, relieving the stored energy and also verifying mechanically something is not spinning and all, you validate all those things. And once the absence of voltage has been verified, which is the step 7, which is the last step, that demonstrates it is safe to proceed further as long as nothing upstream is connected. So
correct, yes.
So going back to the same question, I have a comment to make. I think, Charlie, we talked about it. So in the same question, Charlie talks about live, dead, live test. I'm going to talk a small comment about the last step, which is the live test, meaning re-verifying the meter to a known source. Most of the people answered, 68% said it's false, because absolutely you need to re-verify the meter to a known source per NFPA 70E 120.5, okay? But if you want to take the OSHA regulation, CFR 1910.333 B2 4B, okay? I'm specifically reading this, in which they clearly say in the last sentence, if the circuit to be tested is over 600 volts, the test equipment shall be checked for proper operation immediately after this test. Meaning, if you want to just take a stance with OSHA 1910.333, you don't need to re-verify the meter as long as the voltage is not exceeding 600 volts. I'm not telling don't re-verify your meter. I'm telling you there is a kind of a discrepancy between 70E and also 1910.333. Just a thought here, because I was just reading through that and came across this. Yeah, NFPA 70 is a golden standard which asks you to re-verify the meter, which is absolutely correct. And as a safety company from Grace, we also recommend doing that. But for 1910.333, one doesn't need to. Okay. Any comments on that, Charlie?
Well, okay, I'm kind of switching, and I'm not specifically talking about your statement there, but one of the things that, of course, I got another Fluke device here. One of the things, it says we have to check voltage on, it used to say any known voltage source, but they changed it, or we changed it a while back to a known voltage source. So some people think, well, you've got to, if it's AC, you got to check AC. If it's 480, you got to check 480. That's not true. You check your meter on a known voltage source. So technically, we could take a AA battery, a 9-volt battery, to check our meter, and then check absence of voltage, and then check the meter again on that AA battery or 9-volt. Well, most meters, though, require changing the dial from DC to AC. I don't recommend using a battery source if you have to change the dial, because that's another, something could happen. You could change it or forget to change it back. But I do recommend that it's not a requirement, but I think it's going to be better by checking the meter on a voltage source where you don't have to change the dial. With this particular meter, this one, you don't actually, you set the dial up and it reads AC or DC, or AC and DC. So you would really not have to change that. So it could be done, but again, I really like this proving unit because and it does have on the side here a switch for that changes it from DC to AC. But this gives you, I think it's about 235, 240 volts, and it's right there, handy with where you're working. So, and that's showing some of these items where I go. That's one of that particular item gets a lot of interest.
Thanks, Charlie. Well, let's go to the next one, okay? So next question is, per NFPA 70E, under what circumstances it is required to don arc flash PPE when operating a disconnect switch or circuit breaker? Here's the question on the screen. Can you give another 10 more seconds? Okay, here it is, closed. The correct answer is, most of the people got the correct one, any of the above.
All right, so really we don't even need to cover this one, Bhanu, since almost everybody got it right. No,
I mean, only thing I want you to address is importance of maintenance and installation guidelines, right? So that's one of the areas people always don't pay attention to, right? So equipment installation per manufacturer recommended guidelines and maintaining it to ensure that they are in sound condition. So that's only comment I would like to make. Anything else?
Several editions back, in order, we used to have, instead of 4 categories, we had 5. Technically, we had 6, but one of the categories was for PPE was 0, category 0, which means that it was a long sleeve shirt and long pants of a certain material weight. And with category 0, if we were going to turn on or off a breaker, or if we were going to turn on or off a disconnect switch, we had to be wearing category 0 PPE. Well, the committee did away with this, and I think it was a great idea. And they said, all right, if the equipment is in normal operating condition, no PPE is required. All right, so if you've got a disconnect switch that is in normal operating condition, then you can turn it on or off without wearing any PPE whatsoever. These normal operating condition includes things like it's properly installed, it's properly maintained, there's no openings, there's no evidence of impending failure. If there is any of this, then the equipment is not in normal operating condition. Therefore, you would have to wear arc rated, or you would have to wear proper PPE when just turning this on or off itself.
Okay. So Charlie, I mean, I'm going to go back to the very first question. There was a follow-up question on that about the retraining on the safety related work practices, right? So we talked about the correct answer was 3 years. The question that time audience asked was, what about when there are changes in NFPA 70E requirements, right? So if the NFPA 70E makes a change, suddenly within this interim standard, the retraining requirements address the change to that. So what would happen in that scenario?
Well, what 70 says is one of the things we have to teach is changes in 70E. And so right now, we don't, when a brand new change comes out, it doesn't say you have to train immediately on that. but it should, you've got to train on any changes in 70E when that 3-year period comes up. So, and again, there's a lot of companies and a lot of companies that I train for that they want their people to be trained every 1 or 2 years. 70E is every 3.
Okay, thanks, Charlie. So, and going back to the question on the same question what we talked about, right? So, as far as the maintainability and installation procedures, the question here for you, Charlie, is what if you have reconditioned a circuit breaker, right? And you are trying to put it back on to the system. Do you suggest the use of PPE at that time because the equipment has been recently reserviced or reconditioned? Thoughts?
This was yes, there was a new addition in 70E for, let me find it.
I'm sure there is a requirement for that. If there is a modification to the gear or if the breaker has been pulled back, that time they need to.
All right, so yeah, a new in 70E, the operating a circuit breaker or switch the first time after installation or completion of maintenance in the equipment. And it doesn't matter about the condition, the likelihood of occurrence is yes. What that means is yes, and that's a new requirement. So that means you have to wear PPE even if everything looks like it's in normal, or if it is in normal operating condition.
Correct. Thanks, Charlie. I mean, I just want you to explain that. So
yeah, that was a pretty big change.
So the next one is a non-contact type voltage detector can be used as the only method to test for absence of voltage in 280 volt, 208, 120 volt panel. So here it is. So which Charlie was showing, NCVD pen, or they call it tick tester. I'm sure most of the audience know what it is. All right, so I'm going to close this. Are able to see the responses, Charlie?
Yes. All right. The answer is no. You cannot. It's false. It's false. You cannot use a non-contact as the only method to test for the absence of voltage. Well, what do we have to do to test for the absence of voltage? We have to test phase to phase and phase to ground. Well, you cannot do that with a non-contact. And in teaching this, things come up in class, and some electricians, some maintenance people carry these with them in the plant, and so they may use this as sometimes, until I start tell them what they're supposed to do, they may use this as the only method, but this is it's incorrect. We have to test phase to phase and phase to ground. Now, I do not have a problem with using these as a first line of defense, as long as you're still doing all of the tests necessary. Test your meter, test phase to phase, phase to ground, and test your meter again. You still have to do all that, but as a first line of defense, all right, so you go to a motor control center, you shut off a disconnect switch, lock it out, tag it out, you go to the motor, and you're still going to have to test it at the motor. If you don't have a disconnect switch there, you've got to take the cover off the motor and either stick your leads under the wire nuts or somehow be able to get to voltage at the motor to test for the absence of voltage. Well, this non-contact would be easy. It's not absolute. And you still have to test phase to phase and phase to ground. But as a first line of defense, what if you shut off? What if it's mislabeled? Oh wait, nothing's ever mislabeled out there in the factory, is it? Of course it is. Yeah. So if it's mislabeled and you put your lock and tag on the wrong disconnect, you get to the motor, and what if in lighting this up, it says, okay, no, it's still energized. Well, you don't even have to take the wires off to test for the absence of voltage, because it's showing you that it's energized. And so as far as a first line of defense, I don't have a problem with using a non-contact.
Thanks, Charlie. So there's a follow-up question on this voltage testing as well. Do you have to test face-to-face and face-to-ground on cord and plug equipment, cord and plug type receptacle sets, cord and plug sets? Do we need to verify this absence of voltage?
Well, with cord and plug set, it can. And this question comes up sometimes too. You disconnected the cord, you put a cover on it, you've locked it out, tagged it out, or if it's a Meltrick type disconnect, it has a hole in there to stick your lock and tag on. How much longer is it going to take you got to check to see if there's any voltage or release a capacitor, discharge that. So just if someone is used to doing all of these steps, just do that additional step, even on a cord and plug connected piece of equipment.
But if you want to just take just as the 70E as your reference standard, so I'm sure that it's written somewhere, as I read through it before, the lockout tagout doesn't apply where you have full control of the cord and plug set where you can disconnect it. Is it right, Charlie?
Yeah, that is correct.
Correct. Okay. But as a safety measure, a safe practice, if it is exposed conductors, it doesn't hurt for someone to verify for this face-to-face and face-to-ground, just to ensure it's an additional level of safety that you're going through.
Yes. Yes.
So the next one, layering. So layering arc-rated clothing to achieve the PPE category using instant energy method or PPE category method using a different manufacturers. Is that correct method or not? I'm going to launch the question here. So I'm going to leave for 10 more seconds. Leave it there. And here it is, Charlie, as we expected this.
Yeah. The correct answer is false. And Bhanu, I think what we should do in 2 weeks, have everybody come back and we'll take this test again, and hopefully everybody will get all of the answers right in 2 weeks. Now, next week I'm not going to be here, so we have to do it in a couple of weeks. All right, so in 70E, in informative annex M, for Miller, right, for Miller, informative annex M, M.1.1, this is what it says: layering of arc rated clothing is an effective approach to achieving the required arc rating when the layers have been tested to determine the composite rating. M2, and that's just one of the sentences there. M2, there's a sentence: a total system of protective clothing can be determined to take credit for the protection provided by all the layers of the clothing that are worn if tested in combination. And I didn't think of this when we wrote the question, Bhanu, but if one manufacturer gets with another manufacturer and test their clothing together, then yes, it could. But I've never heard of.
Why would different vendors go and test each other's?
No, I know. I'm sure other companies do it, but I'm very familiar with Bulwark, and they have a lot of clothing that they have tested in combination. So maybe it's a shirt that's rated 10 and a t-shirt type undershirt that's rated 5. So instead of it being 15, it may be about 22. And they give you the tested combination rating, but that is from the same manufacturer.
Thanks, Charlie. So let's go to the next question. I think we'll take 2 more questions we have here and then we'll close it out. So this is on systems over 1,000 volts. It is not allowed to use the capacitively copper testers which Charlie is showing on the screen for absence of voltage testing. This is 1,000 volts and above, over 1,000 volts. I'm gonna give another 10 more seconds, not minutes. All right, Charlie, this is very interesting response here. Look at this.
All right, gee.
I was telling you yesterday when we talked about it, I think this is one of the things.
I think some people probably read it too quickly and didn't see the word "not" in there.
I kind of put that "not" in a cap in uppercase as well, specifically.
Yeah, this is 120.5 for the putting equipment into an electrically safe work condition. This is number 7, where we have to test phase to phase and phase to ground. But there's an exception 2 to number 7, says that for systems over 1,000 volts, we do use a non-contact capacitive type tester to test for the absence of voltage. Typically, these are called tick tracers. And so these are used for because you're not going to get a meter. Of course, typically your handheld meters are good for 1,000 volts or less. We're talking about systems over 1,000 volts. Now, this exception hasn't been in 70E all that long. 3 or 4 editions now. For a number of years when 70E first came out, it didn't even it didn't mention anything over 1,000 volts whatsoever. It was, and so I even had emails from people going, "Wait a minute, I'm not testing phase to phase and phase to ground on a 13.8 kV system." And so this was finally added, and I'm glad it was added to 70E. But one of the things that kind of comes up from this about using, I've consulted with a company before, and so, all right, they've got an MCC bucket or a piece of switchgear that has a very high rating. Maybe it is 60 calories of incident energy. And well, 70E says if it is over the arc rating, if the incident energy is higher than the arc rating that can be bought, then you do use a non-contact capacitive tester. But 60, there are arc rated suits over 60. 65, 75. The highest arc rated suit is 140 calories. And so what I've talked with the company about doing, even if it's a high arc rating, that they've decided to do this. Okay, we're going to use, even if it's not over 1,000, we're going to use this. We're going to turn it off, and we're going to be stepping back quite a distance and just using this again as a first line of defense. And I don't think there's a problem with that whatsoever.
Thanks, Charlie. So we'll take this last question. Use of PPE based on instant energy method or PPE category method will not provide adequate protection on unmaintained equipment. True or false? This will be the last question to poll, and with that, we'll conclude. Good, 10 more seconds. There you go, Charlie.
The majority have it correct. The answer is true. Table 130.5C, underneath the table, there's an informational note number 2 that says improper or inadequate maintenance can result in an increased fault clearing time of an overcurrent protective device, thus increasing the incident energy. When equipment is not properly installed or maintained, PPE selection based on incident energy analysis or even the PPE category method might not provide adequate protection from arc flash hazards. So yes, that the use of PPE based on incident incident energy method or even the PPE category method could not be adequate because of the equipment not being maintained properly.
Thanks, Charlie. That's good. I think that concludes most of the questions, and thank you so much, everyone, for joining us this morning and spending your valuable time with us and participating in this live session. And we also have this handouts where we do this expert network program where we provide electrical safety program development and consulting as well, and Charlie is part of that. So if you have any other questions on general electrical safety, please feel free to reach out to me or Nick. And also there is the exit survey. As you exit the webinar, please do fill that responses so that we can come up with better content next time going forward. And thank you so much, everyone, for your valuable time, and have a wonderful day and stay safe, everyone. Thank you, Charlie. Thanks for your time again. Appreciate it.
Thank you.